How to fix multi-frame gen not working in Resident Evil Requiem. Welcome back to Tenebalta. During our rigorous performance analysis of Resident Evil Requiem running on the RTX 5070, the Tenebalta engineering team encountered a critical rendering roadblock. We discovered that NVIDIA Multi Frame Generation technology was failing to initialize properly, defaulting instead to AMD FSR 3 parameters within the in-game engine settings. This software-level mismatch completely bottlenecked the potential of the RTX 5000 series architecture, preventing the proper injection of interpolated frames. After extensive diagnostics and code-level testing in our labs, we have mapped out the exact pipeline to bypass the engine restrictions and restore native DLSS multi-frame generation. Follow these precise, lab-verified steps to unlock maximum frame rates and ensure your hardware operates at peak efficiency. Step 1. Accessing advanced Windows display metrics. To begin our diagnostic protocol, we need to access the core display rendering pipeline in Windows. Navigate directly to your main system settings, select the system module, and proceed into the display configuration interface. This acts as the foundational environment for the hardware-level changes we are about to implement. Step 2. Navigating to dedicated graphics configuration. From the display menu, scroll down until you locate the related settings subsystem. Click specifically on the graphics panel to expose the operating system's application-level GPU instructions. Our testing confirmed this is where the rendering bridge between the Windows environment and Resident Evil Requiem must be optimized. Step 3. Enabling windowed game optimizations. Within the graphics interface, locate the toggle for optimizing windowed games. Enabling this feature directly reduces rendering latency for borderless and windowed applications by upgrading the underlying presentation model. Tenebalta engineers noted this step is vital to prevent frame pacing stutters when multi-frame gen is forcibly injected. Step 4. Assigning high-performance GPU preference. Proceed into the advanced graphics settings to manually assign hardware priority for your applications. You must explicitly select your high-performance RTX 5000 series GPU from the drop-down menu, overriding any automated default selections. This guarantees the operating system bypasses any integrated graphics logic and routes all heavy frame generation workloads to the discrete silicon. Step 5. Activating hardware-accelerated GPU scheduling. This is a non-negotiable requirement discovered during our hardware diagnostics. Locate the hardware-accelerated GPU scheduling toggle and switch it to the active position. This shifts critical VRAM management directly to the GPU's onboard scheduler, which is a mandatory prerequisite for NVIDIA advanced frame generation algorithms to function. Step 6. Executing a clean system reboot. The Windows architecture requires a complete memory cycle to properly integrate the new rendering scheduling parameters. Restart your machine immediately to finalize the hardware acceleration activation. Skipping this critical system reboot will cause the subsequent NVIDIA application configurations to fail silently in the background. Step 7. Launching the next-gen NVIDIA App environment. Once the system is back online, open the unified NVIDIA App, ensuring you have the latest architectural version installed. Navigate directly to the primary settings console within the application framework. Our investigation revealed that legacy control panels lack the necessary telemetry hooks for the new multi-frame generation overrides. Step 8. Enrolling in experimental features. Inside the NVIDIA App settings, you must manually opt into the beta or experimental features program. Checking this enrollment box unlocks hidden developer-level rendering branches within the driver software. Without this specific access, the advanced multiplier functions required for Resident Evil Requiem remain permanently locked out. Step 9. Navigating to global graphics parameters. Return to the main dashboard of the NVIDIA App and enter the dedicated Graphics tab. From there, select the Global Settings subdivision to apply our custom fixes at the driver level rather than the local application level. This strict global enforcement ensures the game engine cannot forcefully revert back to AMD FSR 3 upon launch. Step 10. Initiating the DLSS Override function. This is the breakthrough configuration Tenabalta's testing team uncovered to successfully bypass the game engine's limitations. Locate the specific parameter labeled DLSS Override within the Global Settings menu. Engaging this override protocol forces the graphics driver to inject NVIDIA proprietary frame generation matrix regardless of any restrictive in-game menu toggles. Step 11. Configuring the dynamic frame generation profile. Within the DLSS Override prompt, you will be presented with dynamic and fixed processing modes to choose from. If you choose the dynamic profile, you must first establish your target maximum frame rate based on your specific monitor's refresh frequency. This dynamic scaling approach prevents the engine from over-rendering frames and causing severe display tearing. Step 12. Applying the 6x multiplier for dynamic mode. Right beneath the frame rate threshold in dynamic mode, locate the Rendering Multiplier drop-down menu. Select the 6x parameter to maximize the interpolation algorithm's output capabilities. Our telemetry data confirmed this aggressive multiplier seamlessly integrates with Resident Evil Requiem's rendering pipeline to provide massive performance uplifts. Step 13. Configuring the fixed frame generation profile. Alternatively, if your setup demands absolute rendering consistency, select the fixed processing mode in the DLSS Override menu. For this fixed pipeline, simply isolate and select the 6x parameter without defining any upper limit thresholds. This instructs the tensor cores to maintain a relentless 6x frame generation output for all supported rendering scenarios. Step 14. Validating the 4x fallback mechanism. Our architectural analysis indicates that establishing these baseline overrides also activates a highly stable fallback protocol natively. If the engine ever encounters an unsupported rendering sequence, the driver will automatically downgrade to a standard 4x frame generation multiplier. This dual-layer configuration ensures absolute system stability across both supported and unsupported game environments. Step 15. Verifying game core repository integrity. If the multi-frame gen metric still registers incorrectly in the menus, your local game repository may be suffering from corrupted configuration files. Open your primary digital storefront launcher and initiate a comprehensive file verification scan immediately. Tenabalta recommends this step to force the engine to redownload any compromised or modified graphics libraries. Step 16. Performing a clean installation of display drivers. We discovered that a corrupted driver cache can often block the override commands from successfully reaching the executable file. We strongly advise executing a completely clean installation of the latest NVIDIA drivers, deliberately wiping the previous configuration cache during the setup. This establishes a pristine, uncorrupted pathway for the 5000 series architecture to deploy its full feature set. Step 17. Auditing DLSS library files. During our final deep dive, we observed that outdated local dynamic link libraries can trigger the engine's hard-coded fallback to FSR. Navigate directly to the root installation directory of Resident Evil Requiem and manually inspect the internal DLSS binary files. Ensuring these specific rendering libraries strictly match the latest SDK parameters is the ultimate guarantee for flawless multi-frame generation. Don't forget to follow Tenabalta for more.